Okay, it should be recording now.
Cool. Yes, it is.
Share. Okay. So for question, we're waiting to do question 2. For question 3, we said it would have skidded 4 times as far because it's mass times velocity squared. So, yeah. And we said that we both have the amount of gravitational potential energy at the top because the distance, it's not the distance you travel, it's the distance, like, just the height.
Yeah, and it's also not like how long it takes you to get up there either. So
Can y'all see my screen?
yes.
I'm just making sure.
Yeah.
Okay. I like to do this just to, I think it helps.
Yeah.
When you throw a
nice.
pebble straight up in the air, it reaches a maximum height h with no air resistance.
So do we set that one up like the gravitational potential energy is like equal to the mgh, or no, equal to mv squared?
My heart says square root of 2 because we're trying, it's like this one, but instead of 4, you're trying to go 2, and that makes sense to me.
Yeah. Okay.
Because if you square this whole thing, then you'd get 2 times velocity. Right? Does that make sense? Don't let me lead y'all astray. Please say things.
This one was one that was confusing to me, but I talked to a couple different people and they all came to the conclusion of square root 2v, so I think that one's correct.
Okay.
Yeah, I like that one. Because the 4 from the last question, it's like it kind of works out. Yeah.
I remember, so for question 6, I remember there being a thing about the slope not mattering when it comes to speed.
Yeah, with like frictionless surfaces.
Wasn't it the same distance though? Part of me is like looking between X, Y, and Z and seeing that Z has a lot more distance-ish, but I don't know if the question was talking about like overall distance where they start and end, or actual distance covered through the slide.
Yeah. Because you can look at, I don't like this.
I think what happens is that they're all the same at the bottom because it's frictionless. Really what's happening throughout it is just a transfer of potential energy because they all start at the same spot, so they all have the same potential energy, and it just transfers between potential energy to kinetic energy. So in X, it just transfers straight from potential energy to kinetic energy, whereas in Y, it kind of plateaus a little bit, and there's a little bit of potential energy and kinetic energy, and then eventually it's all kinetic energy, whereas in Z, we get it's kind of the same thing. It kind of fluctuates between the two, but since it's frictionless and so there's no extra force acting on it, it's conserved, and so the speed will be the same at the bottom for each of them.
Yeah.
That makes sense, yeah.
Oh, question 7 is pretty simple. We covered this in like the first week here.
What?
Question 7 is pretty simple. We covered this in like the first week here. It's the third one, yeah.
Yeah. That feels tricky to my brain.
Or she's trying to like trick us and like, wait, I should probably read this more just in case.
I just did I think it was one of the extra credit problems on the chapter 10 after class homework one, and it led to the work could be either positive or negative because it was asking like a question about that. So I'm pretty sure that 3 is correct. And I've talked with a lot of other people since I've mostly finished my quiz already, or final already, and that's what everybody else was getting as well.
Okay.
And I think, yeah, because you can define positive or negative by whichever way. So yeah.
Okay. I feel like it has to be 1/2 kc because the car is going to have less kinetic energy, right?
I think the best way of trying to solve this is just it tells you the truck has 4 times the mass of the car and has twice the velocity. And so I just chose a mass for the car and a speed for the car and then solved that and found that KT equals 16 kc.
That's true. That makes sense.
I just divided that out and found it was 16 times what the kinetic energy of the truck was.
Mm-hmm.
It's velocity squared. Okay.
Yeah.
Yeah, and then times 4, right? So it'd be 16, like 4 times 4.
Yeah, I think that makes sense. I can kind of see how that makes sense. 3 cars, car F, car G, and car H are moving with the same speed and slamming their brakes. The most massive car is F and the least massive car is H. The cars of all 3 tires have identical coefficients of kinetic friction. Which car travels the longest distance to skid to a stop?
This one I was having a little trouble with because it seems a little obvious, like you want to say it's the most massive car, but that would also increase the normal force, which would increase or decrease the stopping distance. So
I remember
your
I
guys'
would-
input on this.
there was a question.
There's
Yeah.
a question exactly like this, and it ended up being the most massive car.
Yeah.
Yeah, that's exactly what I was gonna say.
Okay.
Yeah, sorry to cut you off.
No,
Is there an
cool.
equation that describes
Pretty
this?
sure, sorry. I'm pretty sure that question was actually talking about something else because I remember in this one, like the overall momentum needed to keep the car going and the friction like cancel each other out, so they're all the same, I think.
Okay.
Yeah, I remember there being a question like this.
I
but
think that question is
remember
asking something
But I
else.
remember the answer being they all travel the same distance.
I'm gonna go check that one. I'm pretty sure it was on quiz 7 and see how similar it is.
Okay.
So I'll double check
Yeah.
that one.
Isn't momentum like mass times distance or something? What is momentum? It's mass times something.
I
Mass
think
times
because it
velocity.
says-
Mass times velocity. Okay, well then, yeah. If they're both doing the same thing, then yeah, the bigger mass is going to have the bigger momentum, which means it's going to take more to stop it, which is going to like take longer to stop it.
Yeah,
Yeah, that
going
was
off
my
of
reasoning
that,
as
if
well.
they all have the same like coefficients of kinetic friction,
Yeah.
then that's why it's gonna go first.
Oh, great.
This is a
multiple
question
step.
taken directly from one of the things.
Oh yeah, this one was from the quiz,
Mhm.
and it's like the same question.
Yeah, the next 2 or
It's the-
3 are actually all from quiz 6, I'm pretty sure.
Oh,
It's
okay.
the magnitude of the change of momentum of the 5K ball is equal to the magnitude of change of momentum of the 10K ball, and then another one. Equal, and then magnitude of change of velocity is greater than that of the, it's these two.
Yeah,
I
the
think.
5 is greater, right, than the 10,
Yeah.
Yeah.
because the 5 stops completely, and then the 10 only starts going a little bit, right? It's like, yeah.
Yeah, the magnitude of the ball's momentum was the same just before and just after the bounce. And then you're standing on a skateboard, catch the ball. Right?
Mhm.
Is it
This
catch
one
the
Or
ball?
no, it's deflect
I
the
thought
ball.
it was
Deflect.
deflect the ball.
Yeah, deflect.
Sorry,
yeah.
I can't read I have it, I wrote down all of the, most of the answers when I retook the quiz, and I can't read. This is false, because you can have a torque without an object moving, right? We've done equations where
You
we've
can have a
calculated
torque.
the torque without calculating, without the object moving.
Yeah, but I think this one's true because it's saying the sum of both the external torques. And so they just have to cancel
Oh,
out.
yeah.
It doesn't mean that there's not a torque on it.
Yeah.
Yeah.
Okay. This is where we're gonna. Pardon the art. Okay. All right. So that's how I'm setting this up. I don't know if that's helpful, but. I'm just gonna do it on my own. Please tell me if the stuff I'm doing is working or not, because I'll stop doing it if it's not.
So I'm assuming this is going to be like a sum of torques problem, right?
I don't know.
I think like because they have to balance out at some point when they're both like up, then like the torque of the child plus the torque of the force equals 0. I'm not sure where to go past that.
Yeah, I assume that we just set them equal to each other and then solve.
Yeah, the two forces are gonna have to equal each other. I think it's just gonna be distance times, for the child, just distance times weight times 9.8 meters per second. And then the other side will just be distance times 220 newtons, right?
Yeah, that's right.
Is that what anyone else is doing?
Yep.
So if you set it up to solve for distance, I got basically 1 meter. There's a bit of, fractions, I think, because, I'm not using the exact number that gravity is, but I got 1 meter.
I solved this the other day, and to be honest, I can't remember exactly like what formula I used and stuff, but I also got 1 meter.
Yeah, I just got 1 meter. So for folks who were wondering and watching this back later, this is basically what we did. That's basically what we did.
We can come back to it later or do it now, but I did go back to quiz 7 and find that the wording at the question is slightly different at the end. The quiz was asking for which car is the amount of work done by friction in stopping it the greatest, and for that, the most massive car was the correct answer. But in question 9 on the test, it's asking which car travels the longest distance to skid to a stop.
And I honestly think if all of their coefficients of friction are the same, that they would travel the same distance in stopping.
Yeah, it kind of depends on what the work is that goes into it, because I'm thinking like, you have to solve for force, it would be the force of friction, and the one that has the most mass would therefore also have the largest normal force. So you've got a larger force going into it, but it kind of depends what work is equal to.
Yeah, but the largest car would also have the most inertia. So I think when you account for it, yeah, the normal force changes, but I think it should cancel out.
I do too, honestly.
So you're saying that the most massive car would still be the correct answer, or that they'd all travel the same
that they'd
distance?
all travel the same distance, because it's all dependent on, I don't know how to phrase it.
I'm putting out the bad signal on the server.
Basically, since friction, static and dynamic friction depend on the normal force times the coefficient of friction, and since the coefficient of friction is the same, I think that which normal force, which relies on the mass of the car, will cancel out with the inertia of the car, which also relies on the mass of the car.
Right, that does make sense.
Because I think the only thing,
distance.
The only way that mass would impact how far it goes would be if we were taking friction into account. In my mind, at least. I don't know if that's true, but it's how it feels.
The only thing that makes me stop is that like I'm kind of torn between the two, because if the friction's the same for each of them and each one of them has a different, force normal, then is it affecting each one of those cars differently? Like if they all had the same mass and the same coefficient of friction, like I totally agree. But like with the mass being slightly different, like does that mean that the coefficient of friction is affecting each one slightly differently?
Yeah,
mean,
like
that's
we're
what the-
still accounting for friction. It's just that the coefficients like all the same.
Yeah.
Yeah.
Plus the quiz question that asked how the coefficient of or how the friction was affecting the cars tells us that they are being affected differently by that, right?
Yeah.
Exactly.
But that's a different scenario. Where different things.
It's a
It's the
similar.
same scenario.
It's the exact same scenario. It's just asking whether or not like the work would be different, which it would be.
Yeah. I agree with what you're saying of like, we can clearly see in question on the quiz that the kinetic friction does affect each of the cars differently based on their mass. So why would it not affect the distance as well?
Mm-hmm.
Yeah, I was thinking like the formula, the P equals mv, right? Momentum is mass times velocity. If the velocity is the same, then momentum is going to get bigger as mass gets bigger. And if you have a bigger momentum, then it'll take more to stop you. And if the coefficients of friction are the same, then like the road's stopping each one at the same like speed, like with the same force. And so then the one with the like largest mass would travel the farthest. Like it'd take longest for that to slow down the biggest car. Because it has the most momentum.
Yeah, I think I agree with that.
Well, we need someone to be our sacrificial lamb then. Well, maybe it won't tell us if we get it correct because it is a final, but
Yeah, I'm thinking that it'll probably just tell us how many questions we got right out
Yeah.
of like 17 and rather than showing us the correct answers, it'll probably hide them. All right, I think we should probably continue for now then, since we haven't really come to a conclusion there.
yeah, we're just wasting time on this for now.
I texted a couple different people. So we're gonna wait and see on that one. I think we should go with the most massive one for now and change it if we hear otherwise.
Yeah, I don't really know how to articulate it, but my gut says it's the most massive one as well. So
I mean, that is kind of what your physical intuition tells you, right? Because
Yeah.
in practice, when you're on the road, like big ass cars take a while to stop.
yeah,
So
exactly.
yeah.
We'll see.
Okay. A uniform piece of medical apparatus. That's a funky word. It's 3.5 meters long. Okay. I don't like this one. I keep getting tension and torque mixed up in my brain because they both use T. Yeah, because I think this example problem that I have is using torque. Is torque the one that looks like this?
Yeah.
Okay.
Work is the Greek letter one.
Okay. can't remember having to do one like this that has distances like a torque problem and no angles.
There is one like this actually. I think it came from the textbook though.
Yeah,
But
I
have
forget
it
which chapter
somewhere.
is from.
Yeah, I wrote it down in my notes.
Oh
Just
boy,
have to
question
find it.
17 is really stumping me here.
Yeah, definitely a tough one.
I did this question like a few days ago. I don't remember like how I did it, but I got the 9-10 one.
Okay, well, we'll keep that in mind.
Yeah, but yeah, I can't remember what I did.
That's what I also got. But I'm trying to look to see where I wrote notes about this.
Yeah,
so
I'm
I
looking
can
through my
share with you
work right
guys
now too.
how I did that. Oh, here we go. It was in question in chapter 8 of the textbook. Looks like I pulled it from 8.1. And yeah. And then we did one similar question in mastering, it looks like, because I wrote that down here too.
So it's in the textbook?
Yeah.
I mean, you know the torque has to equal 1750, so there's only like 2 possible answers. And that's, yeah, one of the last 2.
Wait, this 8.1 is torque, not tension.
But it's asking for something really similar. It's asking for the normal force of what's holding it up. And this one's asking for force of tension, which is what's holding it up.
Oh, wait,
well.
you could just solve this in your head. So yeah, so it has to equal 1750, right? Because that's the weight of the block plus the medical apparatus.
Yeah, and it's
you
closer
know
to
that
the left side.
Yeah, it's closer to A, so you know
So
the A is
it
gonna be
literally,
larger.
that's the only one that would make sense. So you
Yeah.
can kind of just like
peasy.
logic it out.
Who
That
needs
does make
physics?
sense.
Yeah.
Well, now we have to do one that actually, do we want to do this one first or do we want to do question 2 first?
I think you do 17
Just do this one first.
Okay.
Yeah, 16 too.
Yeah.
As shown in the figure, because question 17 is basically free.
It's basically
I don't
the
know, that was
hardest
pretty
question of the
hard.
class.
That is
Definitely
the
a
bingo
struggle.
square in the center.
Actually, like before I read the notes, I thought I was gonna have to try to remember what she had said about football, and I was kind of freaking out because my eyes glaze over when I have
Imagine
to
if she
think about
actually graded us
sports.
on that. That would be so awful.
Yeah.
Oh my God. I think it said it somewhere like
It's
on
on
her
like
like
the
welcome
Canvas
video.
It says
that
on the
she delivered.
homepage.
It's
Yeah.
right here.
If you
This is
open up
definitely-
Canvas and scroll down, it'll.
Yeah.
Yeah, I know. I just like slight twinge of fear because I don't know a damn thing about a sport.
Yeah, I failed my final because I wasn't listening to my teacher when she's talking about football. Fuck.
College football specifically.
I'm taking
Oh, this is
psychology
really-
of sport next quarter, so this is the only one I feel super confident about.
This one is really similar to the construction worker on a thing eating his lunch, right?
Yeah.
Yeah, exactly.
Because this block is basically just weight. God, I actually found a video of a woman explaining the construction worker problem. And I wrote down everything she said. So if it's already given to us in newtons, then we don't have to multiply it by gravity. So God damn it, what's 180 minus 49?
Okay, I got an answer, but it doesn't make sense. I got 10.2 meters.
That's also what I got.
Hold on, I'm not there yet.
And yeah, that seemed really funky to me because it's only 10 meters long. So I thought, well, maybe it rounds to 10 meters. But still, it seems weird that she'd give us one that was slightly over.
Yeah.
Yeah, I had the
I'd
same thought
agree.
process. Like it was like just over 10 and that was like confusing me.
Yeah, so I thought, well, maybe it just like, 2 would round down. So maybe it's just 10 all the way out at the end there.
Does she grade significant figures?
I
No.
I
think
don't think
on
I don't know.
exam she does.
Does she? I don't know.
Yeah, I got something absolutely bonkers, so don't even look at me.
Big fig should be 10.2 anyways, though, right? Yeah,
But
one
10.2
sec. Except
makes
unless you
sense.
count
I don't think
degrees.
for the degrees we would round down because that's like that doesn't affect sig figs.
Yeah.
Everything else is out to 3.
Yeah, so then it would be 10.2 rounded to 3 sig figs, which is what it should be. But that just seems so weird. But I'd agree, I'm getting the same answer and I'm following the same notes, and I don't see how it's any different than like I went back and kind of changed around, like solved the other question where the man was sitting on the beam and like plugged in the correct answer that I found and then solved for distance the same way, and I found the correct distance. So I think we're going about solving it correctly. I mean, we could always try asking her. She will answer some questions, but I'm not sure what she'd say
I think
back.
this one might have just been set up funky.
Yeah.
Like It's possible that like the only way you can get that many newtons is by having it be out that far.
I
Yeah.
think I'm gonna also, yeah, I guess we should, I'm also gonna put out the bat signal on this one.
To Linda or just to like other people in the
Just to
class?
the Discord. I don't know if anybody's gonna answer because it's really variable whether you get an answer or not on this server. I don't know what I did, but I did something wrong.
What did you come up with for an answer?
21.
Did you multiply, did you use 9.8 with the 66.5 newtons? Because I actually did that the first time.
Yeah, let me look. Hold on.
You add 9 and 10. Oh, come on, nothing. Damn.
What?
Never mind.
I got it. Don't worry.
Thank you.
Oh, and I was gonna reach out. Sometimes she'll say on the like quizzes whether or not to put units on it. And so I assume that she doesn't want us to put units on it since we don't usually do that when we write in ones like for 16 and 2. But it doesn't say anything about that. So I don't want it to like automatically grade it wrong.
I put units on 16 because you like can, but if you try to type anything in 2, it doesn't let you.
Oh, okay.
Gotcha.
I mean, I think since she didn't specify, I'm pretty sure that she'll probably take both. She's pretty like reasonable when it comes to, you know,
Yeah,
stuff like
she
that. So I think
definitely-
she, yeah.
She definitely wouldn't grade you down for writing meters, so you might as well.
Yeah.
Exactly.
Yeah.
That's also not right. I got 0.5. That's also not right. Cool. I don't know
That's
how I'm
funky.
setting this up. I think I'm just doing it wrong, but I don't have any idea how to set this up. So I just set it up like the other one, but
I think the computer grades it. So and when you add meters to it, did you put a space in between 10 and meters or just the no space?
I put a space, but I'd imagine she would like take a look at it.
Yeah, I
it
hope
might-
she
it
would
might
too.
not
I
be
just
auto-graded.
can somebody
don't want it to
please, for
scare
the
me.
love of God, tell me how they're setting up this problem?
yeah, I just erased my work, but I'm happy to do it again. Don't worry. Let me find where I wrote this down. So basically, what I'm doing is adding the weight and weight and distance of the two, and so I'm doing so for the unknown mass. So the mass is known. The distance is not. So it's 10 kilograms. So 10 times 9.8 since it's in kilograms, and then times x because we don't know that distance.
I'm going to show you how I'm setting this up because I know I'm not setting it up right, and I also can't follow you when you're just saying, like, it's very difficult for me to follow what people are saying when I'm just hearing them.
So are you solving for torque or tension?
I don't know.
So if I can explain, if it would be more helpful, I could like share my screen and try writing on it so you could see it that way, because I
Yeah.
think you're going about it a really different way than we were. Let
me see if I can allow. God, I hate like trying to run a Zoom. I hate it.
It should be the security option and then like the little arrow, and then you should be able to click allow all participants.
Okay,
to
there we
share.
go. You should be able to now.
Okay.
I just tried to set this up the way that the other one is set up, but I don't.
Yeah. So if I go to, this is how I set up the other one. So you can see that I took the mass of the guy that was sitting on it, which was 80 times 9.8 times the distance from the wall, which was 4, and then plus the halfway distance of the beam times the weight of the beam. I mean, the mass of the beam times 9.8, and then that was equal to the force tension times the distance from where the tension was connected to the beam times the sine of the inner angle there. So then if I go to just another.
So I did it completely differently. I got the same answer.
Anybody else? Wait, so you got to the same answer for the other one?
Yeah, but this is what I did. I just posted my work in session planning. It's loading.
Funky. Because for this one, what I did was the same thing I basically just showed with 10 times 9.8 times the distance we don't know.
That's what I did for the, I posted it in session planning.
Yeah, so you did basically the same thing. You just solved it in different parts and then set them equal to each other.
Okay, that's what I tried to do for this one, and I still couldn't get it. So whatever. I have dyscalculia, so.
It seems similar to me.
And we don't need to submit work for question 2, right? Or do we?
I mean, I don't see the option to.
Yeah, there's no upload or anything for it, so I don't think we have to.
Okay.
I don't think so.
I've just had such a truly terrible grasp on physics this entire quarter. I'd be struggling.
Yeah, 115 and 116 are going to be such a blast.
Thankfully, I only had to do 114.
Yeah, I only have to take one of these, so
yeah.
Get right.
Bye.
Just enough for the MCATs.
Is anybody else taking 15 and 16?
Yeah, I have to.
Yeah.
Yeah, I have to take it.
I'm putting it off until next year, though.
Valid. So do we have to like input an answer for the first question? Just to like get it to,
I mean, Canvas is gonna warn you that you didn't answer it, but I don't think
Yeah.
so.
I'm just gonna
Yeah, I
say
was just-
0.
Same. That's what I put in there.
For question 2, are we assuming that the purple box is sliding down the hill, or are we calculating how much energy is lost as box 1 slides up the hill?
It's as the box slides up, the purple one doesn't move.
Yeah, I assume the purple one is stationary until it's hit by box 1.
It doesn't say that. It just says the gold box has a mass of something, of whatever it is, and the purple box has a mass of 3.7.
Well, I
All
mean,
surfaces are frictionless. What's the velocity if they stick together?
I mean, we have the arrow that just says that the gold box is moving at 16.3 meters per second, but there is
Yeah, so
no
it
given
has
velocity
the
for the other
velocity to
one.
the right.
So it can
So-
be assumed that box 2 is not moving.
Is it just me, or have we not calculated something like this where it is moving up a hill like this?
No, I don't think we've done anything like this. There was one question similar. There was an extra credit on the chapter 10 homework, but even it was a little bit different.
Everybody's saying they got 4 meters per second in the Discord
Yeah.
server.
Yeah,
Yeah.
that's what I got.
Same, that's
Cool.
what I got too.
Mhm.
I don't know what to round it to though. Because like my answer is like 4.01. So I guess
Then
what,
it should be 4.
so then yeah, it's 4.0, I guess.
Yeah, it should be
because of the
4.0
2
then.
figs.
Oh, actually, it clears it if you try. and
Yeah,
put
it makes it 4.
decimal. So
Really?
That's nice.
Oh,
Helps
yeah.
you out.
yeah,
Oh, huh. Oh, and is this the one where you can't put like meters?
Yeah,
Or,
yeah. For question
you
2,
can't
you
put
just have to
numbers.
say 4.
Oh yeah, only wow. Look at that.
Alright.
Jesus.
Who's ready to submit?
I'm not going to submit it until I hear from other people in the Discord about those
Yeah.
2 questions.
Yeah, because
Yeah,
I'm
we're
gonna be
scheduled.
real. Like, I saw my grade for exam 2, and I was like a little stunned.
Yeah.
Right?
It's really stupid that we
Because-
still can't like see the questions on that.
Oh no, I can see them,
You can see for me.
I
it
can see
doesn't
the questions on
say.
2.
but they
I
only,
think
they only
on
got released
exam
like,
2
like
I
a couple
got
days ago.
if you guys want to compare, I believe I got full credit on that one.
See, I got a 64%, and I know I took it with a few people who are in here
Oh,
right
geez, man.
now.
I'm sorry.
Yeah,
So
we didn't do so well in the multiple choice, but we did. The people that at least worked together, it was like a fairly large group of us, got full points on like the upload portion.
Yeah,
So that's
yeah.
good at least.
Yeah.
yeah, no, because I
Got my
think you
grade
and
up
I
a
work
lot.
together, Annika. So
Yeah.
Yeah, I met with people for that one, and I also looked at like a ton of YouTube videos on like the different things, and that really helped.
When you
I think
guys,
somebody pulled me into a Discord call the night this was due. And after like 3 hours of
Oh yeah,
screaming
Cocoa
at each
Puff.
other.
Yeah, we did it with Gabriel and stuff. He was so good at the problems.
Yeah,
Yeah.
yeah, Gabriel helped a lot.
After screaming at each other for like an hour, I got most of them right. I don't remember why though.
so when you guys went about solving for question 2, did you just use the like inelastic collision equation? And then solve
Yeah.
for B prime?
First, I solved for finding the final velocity of box 1 after it went up the hill using like the initial kinetic energy minus potential energy equals the final kinetic energy, and I found that final velocity. And then I used the equation for like an inelastic collision.
Oh, okay. So were we all gonna wait to submit it until tomorrow?
I am. I don't.
Anyone email Linda?
Yeah, bro, I'm a risk taker. So even if I fail like half of this exam, I'll still get an A. So I'll sacrifice myself for you guys. Don't worry.
Okay.
Thank you, Ishmael.
God bless you, bro.
Oh, you got it. Oh yeah. So I have one and okay. I have the one unanswered question, and I got 15 out of 17.
Oh,
Okay.
okay.
Wow.
But I also
And that doesn't-
I said that it was equal for the 3 cars. So like maybe that's different from your guys'. I
Oh
don't know.
damn!
Yeah.
Okay, well then I'm just gonna submit now because I said
There
that,
it is.
I said it was greater than. So
Wait, which one did you say for the equal?
um,
These are-
You
For
said
the
This is like
car
question
S,
9,
right?
right? The
Um,
car one.
yeah, I'm
Wait, what
saying
did you
car
get?
F.
Yeah.
I got 13 out of 17.
Ooh.
Okay, so it's not
So maybe
that
it is
one.
equal.
Yeah.
Well, I'm gonna wait. Thank you for throwing
If-
yourselves into the brink.
Yeah.
Were the other ones, Ismail, was that the only one that you said different than kind of what the group consensus was?
Yeah, I don't remember.
Okay.
That's okay. I'm just gonna, yeah.
I think I might submit too, since I think you got 15 out of 17, so you just missed
Yeah.
one. Okay,
Yeah.
sweet. I'm gonna do that
Yeah,
too then.
I got 13 out of 17.
And what did, wait, who said that? Said
Derek.
With me.
And you changed yours to car F, right?
Yeah, I said that whichever one was the heaviest car.
Gotcha.
Yeah, because I can't actually view my attempt now. I don't
Right.
think. So
Okay.
But the other ones you said the same as everybody else.
I'm
here.
pretty sure, yeah. Unless I like totally misheard something, I'm pretty sure I said the same thing.
I think so. Okay, I'm gonna go ahead and submit mine because I just want this to be over with.
Yeah.
I'm just gonna do some quick math.
Okay, I got 16 out of 17.
Oh, okay.
So I said everything that we did, and then I changed the question 9 to them all being the same.
Yeah.
I think that was
Okay.
Yeah, I got 15, and I don't really remember, but also
Yeah, I
like,
got 15 out of 17. I don't know what I did. That's fine. I don't care.
Oh.
I'm exhausted.
Yeah, I'll take that.
I'll take
I'm
that. Yeah,
prepping my
thanks,
other
guys.
finals.
Yeah.
Yeah, 15 out of 17 ain't bad.
Okay, yeah, see you guys.
Have a good winter break, guys.
Good night,
Yeah, have
everybody.
a good winter break.
Yeah.
Thank you.
Thanks everybody.
Thank you,
Okay,
guys.
bye.